Hello, welcome back to our video tutorials on Agentic AI for PCB design. Let's get started. So far, I've been showing you how conceptually this whole process work. How do we integrate Agentic AI technique and tools into the PCB design workflow to improve traceability, verifiability, and reusability. So today I want to take this opportunity to show you uh, how can we leverage existing tools to realize the process, something tangible, so you can play with it yourself. So the example I use include Claude Code, which, as you know, is an AI agent, KiCad, which is an open source EDA tool for PCB design. And as for GLC PCB, it's actually a PCB manufacturer and also a part supplier. For my personal project, I actually use that a lot for fabricating those PCB board I designed. But all I want to say is that you don't have to stick with any of these tools or vendors yourself. You can choose anything you want. For example, you feel free to uh, switch to codec for AI agent, and also there are a whole bunch of PCB suppliers and the manufacturer out there. Um, so let's look at a detail. So first of all, a recap of what we discussed so far. If you haven't watched the second video on the example, highly recommend it. Otherwise, you won't be able to understand what I'm talking about here. So the illustrative example we are using throughout this course is about designing a mini robot to inspect underground pipelines. Last time I showed you how can we leverage Agentic AI to help us do some market research, understand our customer needs. At the end of by the end last time, we reached the conclusion, we make the decision that we want to build a PCB to control this robot to focus on this something called a residential serial ladder. And it often has a diameter of 100 millimeters, represented by DN100. One of the reasons we talked about last time is just because this residential serial ladder is something that's taken care of by a contractor, local contractor. Often they have the willingness to invest to pay for the inspection fee. And we also make the decision that we want to build a product to bridge the gap, which is in addition to the DN100 pipeline, underground pipeline. We also want the robot to have some sort of autonomy, such that it can drive itself back to the original location we place it. And also, we talk about we want to have some onboard AI because often the contractor might want to do something to fix the pipe immediately if there's any defect being detected. They don't want to. We talk about they don't want to wait. Maybe they don't want to wait. Maybe they don't want to store those video captured by the robot to a SD card and have someone manually check that offline. So that's what we talked about last time. And we also show, well, after we have with the help of AI agent, after we made the decision, then we can use that to drive our downstream requirements. So here I'm showing you a couple examples. We talk about the requirements could be a physical requirement, like the size of the board, could be related to power. For example, the robot must be operational more than 2 hours without interruption could be related to onboard computing power, because we want to have some real-time detection for the defect of the pipe. And also some requirement might be related to communication or regulation. So after we have these requirements, the question is what's next? So what I want to show you next is the agent AI can actually be used to help you with come up with functional design. Not only that, but also can even help you to pick the most appropriate or maybe most cost-effective component to help for you to realize your functional design. So that's what I want to show you. But before we get into the real the meat, which is the tool integration, I want you to keep in mind this diagram, this architecture regarding how agentic AI agent interact with the tool and a human designer. So if you were a PCB designer or embedded system engineer, after having the requirement, maybe you will start to use some EDA tools. For example, in this case, I'm using KiCad to create a schematic diagram to try to come up with some functional design. What are the microcontroller? Should they have some sensors? What are the motors? How much power we need? And things like that. And you also want to use that to pick the component depending on whether they can fulfill your needs in terms of functionality and also non-functional requirements. But with the AI agents, after we have after we integrated this agentic AI into the PCB design workflow, so what happened is that the AI agent can actually interact with these external tools on behalf of you. So you don't actually need to draw these schematic diagram, PCB diagram yourself. You can actually write some prompts in natural language form in English to have the agent interact with the EDA tools to create a diagram. But also, what I want to point out, not only that, but you can also expect another important functionality, which is maybe think about the agent can actually ask for the price and the availability information from the parts component suppliers, and incorporating these information into your design process. It'll be very helpful if you want to say do some good job on cost control, or you don't want to wait, you don't want to pick parts or component that have a long lead time. So this is something I want to. So keep in mind as I walk you through the tool integration, the real example. So keep in mind, keep this diagram in mind. So all of these are realized through this something called a PCB MCP server. So MCP, I mentioned briefly last time. MCP, or maybe in the first video, MCP stands for Model Context Protocol. You can think of a MCP as a language or the interface or the interfaces that governs the communication between your AI agent and the external tools. So now let me actually show you how it looks like. So this is so before we dive in, this is something I recommend you to read to get a better understanding of what an MCP, what a model context protocol is. So it is introduced originally by Anthropic. The company, as all most of us know, who built the Claude, which is one of the large language model. So if you read this blog by Anthropic, you'll get a better understanding of what a MCP does. So essentially, it gives you an idea of the role of MCP in terms of connecting AI agent or the chatbot with third-party external tools. And so if you're a software engineer, you can definitely write the MCP yourself. But for those of you who just get started in this domain, what I recommend is you can actually leverage. It turns out a lot of PCB designer, thanks to their efforts, they actually published and put those open source resources on online on GitHub website. In fact, if you open Google, you search with the keywords KiCad space MCP space server, you can actually find a whole bunch of KiCad MCP server published by different designers, and you can see there are lots of them, but not only by individuals. Actually, you might notice that there is even one published by Seed Studio, which is a company who built a whole bunch of very nice IoT products. I actually personally use that in some of the ESP32 boards they built. But anyway, so the one I picked is the first one. So this KiCad MCP server published by this designer. I selected not because it showed up on the first line, but it has a star of 1.5K, mean probably implies a lot of people using that. And also, if you look at the last time they commit, it's 5 days ago, meaning this author has been actively maintaining this GitHub website, which is a good sign. So if you read the description, you will get a better understanding of what this MCP server can do for you regarding KiCad integration. So obviously, you can set a project, create a schematic, and place component, do PCB routing, even do a design rule or electrical rule checking. You can use it to write prompts to create the symbols for your library, and also it is very nice. They provide this GLC PCB integration functionalities. So they also post some guideline to walk you through how to install this. But the method I would recommend, if you're not very good at coding, what I did is I actually just leveraged the AI agent. Again, I'm using Claude Code as I mentioned, but feel free to pick any AI agent you are familiar with, you like. So what I did at first is I actually downloaded the GitHub to my local computer. So if we open that, you will see. So I actually download this GitHub website to my local computer, and I actually asked the Claude, saying, "Okay, let's run this command." So it turns out this command is the command they recommend for installing this MCP server on Windows. So you can actually get this information by reading the README file. The author posted. For details, you can also click. If you go to the doc folder, they actually give you a very, very detailed guideline and view on how you can install and operate each of these function, this component. But anyway, so you can use. So the method I recommend to install is just to leverage Claude. So you can see Claude actually detect if there's any missing dependency, like Node.js, you install, and it will ask you, often it will ask you a whole bunch of questions. Sometimes it also make mistake. So here's the tips I often take. I basic whenever Claude or other agent tool make a mistake, I it's almost the case, almost always the case. I just give them some visual feedback. For example, this is the arrow I run into. This is after I install this server. I just ask Claude to create a new KiCad project as a demo. So it did that, but it failed. So I actually gave some visual, just a screenshot will be very, very helpful for the AI agent to figure out what's going on background, help it to identify the error. This is actually tied up to a very important concept called reflection, a very important concept technique in agentic AI to help the agent to figure out a mistake and improve. So after a couple of iteration, it successfully installed the server. And one thing I want to show you is this. So depending on which AI agent you use, for example, I'm using the desktop version of Claude. So after I asked Claude to install the KiCad MCP server, if you go to the folder where Claude installed and try to look for a file called a Claude desktop config, if we open that, you will notice that there something related to KiCad has been written into the configuration file of Claude. So this is saying, this is telling Claude there is the MCP server and where to find this server and how this server is linked to the EDA file, where to find that EDA file on your local machine. So in this case, I'm actually using KiCad, the 10.0 version. So this basically means the installation is successful. There could be other issue, but as I said, you can always ask your AI agent to fix that for you. So after the installation, you can actually start to design. Try to create your functional design and pick the components. Let me show you what we have so far. So again, if you haven't watched the second video on where I walk you through the example of how to come up with this design requirements via market discovery with the help of a AI agent, please do that. Otherwise, you wouldn't be able to understand what's happening here. So after the previous step, here you're gonna get these two folders. Or I call it design artifacts. I mean, the exact layout organization might be different depending on which AI agent you use. But if you take a look at it, what's within this folder, within the market discovery, there are some context or market research done by the AI agent. And if you click what's inside the requirements, so these are, you might notice there are two types of file. One is requirement, which basically specify the technical parts of your PCB board. But there's also something called a design decision, which is, I already mentioned that, but I'm going to show you details. So these two design artifacts, market discovery related to what a customer wants and requirement, is something you should have by now. So just because I already used Claude to do some design offline, so I got some functional design and a schematic design artifact. So don't worry about that. But So you, assuming you have this market discovery and requirements design as a design artifact, what you can do is that you can basically put those files into your local folder, your working folder by AI agent, in this case Claude. And what I did is I basically ask Claude to read the information in the folder to get a better understanding what I want to design. As you can probably imagine, Claude was able to read the requirements we previously defined, and Claude was able to read the design decision we previously defined. Notice that these two files are also generated by Claude or by an AI agent. It's just that it's a generated by another agent that is responsible for that particular design stage. Now we are trying to play with a new agent in this particular design stage, which is functional design and component selection. So it reads the requirements, what the decision we made so far, it's interesting to see. I also asked Claude, what are the optimal multi-agent architecture we should use? Should we create another sub-agent? And you can probably play with Claude, but in my case, Claude actually suggests that there could be two agents for this stage. One agent is called is doing search and evidence gathering, which is it tries to look for parts that can fulfill your needs or your requirements based on JLC PCB's database. As I said, JLC PCB is a component supplier and a PCB manufacturer. But you can also you can also do with other manufacturers or suppliers. It's just that it happens to be this MCP server. There are already some open source code that support the integration with JLC PCB. That's the reason I choose it. It's totally optional. So Claude said, oh, okay, maybe you can play the role of evaluating the design solution proposed by this search and sub-agents. So I agree with Claude's plan. I try to ask Claude to propose 2 or 3 solutions to allow me to achieve the functionality and meet the requirements we previously defined. So because I'm a visual guy, whenever I do PCB design, I like to visualize and see what's happening in the background. So I actually asked Claude to visualize and try to start a server locally such that I can open my browser and see the design process in real time. It turns out Claude was really good at. I'm pretty sure other AI agent will do, but here Claude was able to create what I asked for, which is it created it started these 2 local hosts such that I can open my browser to see what kind of a solution Claude is proposing and what kind of parts Claude selected for me. So let's take a look at how it looks like. So this is the first browser I opened. As you can see, this is a purely defined, created, visualized by Claude. I did nothing. I just giving the Claude my requirements. So you can see, first of all, Claude actually summarized the 3 design decisions we talked about. We came out with last time. The first one is the decision on we want to focus on the residential sewer lateral pipeline, just because it turns out there's a niche market there. We faced less competitor. And the second design decision we made last time is we want to target a general local contractor because they often have a more willingness to pay. And the third decision we made last time is we want to build a product that fulfill this gap, which is underground pipeline has a diameter of DN 100 millimeters. It must have some autonomy to drive itself within the pipe and get back to its original location where we placed it. And we also want to have some onboard AI capabilities such that it can do some defect inspection in real time. So you can see what the AI agent does is that it takes the high level design decision we made and it tries to refine it to lower level design decisions. For example, let's take a look at here. So it turns out that the AI agent automatically refine these 19 design decisions for us. For example, obviously the first one is those are high level. These first one are high level requirements, right? Target pipeline with 100 millimeters. Customers should be general contractor, more willingness to pay, and the differentiated target is autonomy plus onboard AI, right? And it also has some other design decision made for us. For example, the deck means design decision. The decision number 8, illumination duty cycle. So this is so if we read this. Mission average target roughly equals to 30% full illumination plus full AI capture and 70% drive only. So what it says, if you are not comfortable with this explanation, you can ask Claude to explain it in detail. But what this design decisions says is that we for the whole operation of the robot. 30% of the time, we might need to do a illumination of the background, just because within the pipe is pretty dark. So if we want to have some camera to capture the defect within it, we might need to, put some LED to illuminate, to light up the background. So that actually will draw some power, as you can imagine. But 70% of the time, it is just drive only. Meaning it doesn't need to even in the low visibility condition, if we can have a camera that can even work in those scenarios, we don't need to always light up the background. We don't need to always capture some high resolution images, videos. It seems in mind again, these are what AI agent proposed or decision made for you. So think of this as an evidence or maybe something to help you make a design decision. As I addressed at the very end of the previous video tutorial, you as an engineer, you are the boss. You still need to take the initiative. You still need to try to make the decision yourself. What Claude does, it only help. What AI agent does, it only help you to aggregate evidences for you to make the informed and reasonable decision. And you can see there are other design decision it made for us. For example, this is design decision 30, called a view coverage solution. But it says defer to functional design, and this is because this view coverage solution is saying if we run this robot within the pipe, basically what we're interested is what's happening on the two sides, right? Because those are areas where we might expect the defect of the pipe. But if we put a camera in front of it, it might not be able to capture the very clear. The image or video might be blurred, right? Because you're actually moving. So that actually requires some judgment or engineering decision on the functional design of your system, whether you're going to put a multiple camera front camera to side camera, whether you're going to have a rotating camera, things like that. So that's the reason why Claude is suggesting that let's defer this design decision to when we get to the functional design stage where we need to pick the components. So these are design decisions Claude made for you, right? If you look at the design decision hierarchy, high level design decision these three we made, then Claude can refine it on your behalf. But at some point, you still need to try to come up with try to make further decision to proceed. And also, there are a whole bunch of design requirements derived from this design decision. You can see, we mentioned this briefly earlier, but you can see there are physical requirements. For example, there are requirements on the board size of the PCB board, because you need to, not only the robot itself, the PCB board that control the robot do the sensing still need to fit in with the pipe that has diameter of 100 millimeter, and there's also requirements on sensing on the sensor, and you can see the first requirement related to sensing is we want a continuous full circumferential imaging of the pipe at a defect grade resolution, right? So as I mentioned earlier, what's interesting to you from a defect inspection point of view are two sides, right? If you're a robot moving, what's in front of you might not be very interesting except for the navigation purposes. So that's what a clock the requirements derived. There are also other requirements. For example, requirements relate to localization, memory, onboard computing power, whether we want to only have one MCU or we want to have an individual NPU, things, requirements on power, and also the requirements on communication, because there are probably no wireless communication within the pipe, right? So these are what Claude summarized for you, and basically it basically tells you, well, to proceed, you need to resolve the issue. You need to make a decision on what are your sensing architecture, the functional design of your perception architecture to be able to proceed, which is decision 13. We talked about this. So we talked about this earlier. So it turns out that we can also leverage with the help of AI agents to come up with some solution for you. So this is the decision you need to make relating your sensing perception architecture, Claude Code view coverage architecture. So you can see here, this is what I mentioned, right? So this is the three solution. By the way, I didn't do any of this. Claude did this automatically for me. You can see there are three solutions my AI agent proposed. One is it basically saying, well, we can always leverage the camera we put in front of the robot. But in that case, if we want to do the scanning or see what's the two sides, the defects of the pipe, we probably need a mirror. And the second solution is, okay, in addition to the camera, front-facing camera, we might need a side-facing camera that actually capture, what's happening in the two sides, right? And the third solution is, okay, let's put this camera in a stand motor that can rotate, right? So meaning you can use the same camera to not only look for in front of you, but also the two sides, the left and right. So you might notice that Claude actually the recommendation by the AI agent is actually not a arbitrary or random. It actually based on a couple of criteria. Those criteria will be from the early requirements you defined. Cost is also obviously there is a we always want something cheaper, right? The balancing between cost and the effectiveness. But if you look at what's happening here, so the AI agent can actually help you treat and balancing among different requirements, right? So not only for example, this second option for dual camera, front-facing camera, side-facing camera, it is good at capturing what's not only the front but the two sides. It has a high resolution, right? In both of these criteria achieve 5 score, but from another perspective, which is electronics simplicity or cost, it might not be good, right? So at the end of the day, you have a score, so you can make the judgment on okay which one is better. But notice that among these requirements, there are two I want to draw your attention. One is BOM cost. BOM represent bill of material. Think of it as a component cost. The other is supply risk, stock depth, meaning the availability, right? You don't want to order a component that you need to wait for a long time, right? So those are things you might want to consider. Even if you don't use this agentic AI tools technique, the point of design is or PCB design is you still need to go through the thinking process to have some criteria, functionally, does it work? How much cost? The lead time? How long you need to wait? Is it better at capturing, what's happening in the environment as a sensor platform? Things like that. And the simplicity in terms of electronics, but mechanical simplicity, right? So, but here the AI agent actually does that for you. So you have some recommendation. So the thing I want to mention is that these two, cost and stock, these are real time, right? Thanks to the MCP server, these are information that Claude was able to extract directly from GLC PCB's search database. If you want to know detail, you can click here, right? You can see in addition to these to the functional architecture we talked about earlier, right? Those three solutions, A, B, C. Clock even pick help you select some components, right? The compute module, power module, but also it give you idea of if you go with a given solution, which component is the optimal choice, right? You can see, for example, this is the inspection camera, the side-facing camera. So if we look at what this side-facing camera is about, right? So if we read this, you will know that this seems to be a good fit for our purpose. If you read this, these improvements allow the sensor to produce clear, low noise images in both low light and bright scenes, and in high temperature environments. This performance enables the required eye tracking and gesture detection functionality in 3D scanner and gesture recognition devices. So just based on the description, it sounds like it makes some sense, right? If you really think about what we want this side-facing camera to do, in other words, capturing the defect on the two sides of the pipe, right? So going back to these three solutions, And now this is what I want to show you, right? The power of using Agentic AI to enhance PCB design workflow. I mean, don't get me wrong. I want to address again, as an engineer, you still need to, go through the whole design process, taking the thinking process, taking your initiative, using your judgment, your taste as an engineer to make all these decisions. But what AI is good at is really try to summarize, provide this evidence for your decision making, right? And if you think about here, these evidence they are based on the real-time information on the inventory of the supplier, right? So it's not just the functionality, it working in function, but also it's also about whether you can pick some component with a lower cost, with short lead time, right? So you don't need to wait. So these are something that I would say this Agentic AI approach can help you with. So after I have these solutions, what I did next is, okay, I can have Claude to continue the design, right? Like here, if you look at what I did, I basically tell Claude, okay, let's go with solution B. Again, this is just the examples for illustrative processes. B might not be the optimal solution among the three, and even this solution might turns out totally doesn't make sense. You should try yourself. But here, my point is, maybe I'm convinced by AI agent that B is a good solution based on this tangible evidence it showed. It just at least it justify to some certain extent, right? So and also I also tell AI agent as example, can you actually create a schematic diagram with the exact component you selected for solution B, such that I can use KiCad to inspect. So after a couple of iterations, it turns out that Claude actually created this schematic diagram automatically for me to checking within KiCad. Let me actually show you how it looks like. So this is, as I said, I'm actually using KiCad, the open one of the open source tool for PCB design, right? So this is a project created by Claude. I didn't do anything. And if we check what's within the schematic diagram, you can see this is automatically generated by Claude. I didn't do anything. It looks like with the help of the MCP server, Claude was able to operate KiCad to put this component for me. Like this, obviously microcontroller, but I assume there's something related to power, right? As you can imagine. And I'm pretty sure there's something for sensor, camera, things like that. Yeah. Obviously, it's not perfect, right? If you dive into detail, you might notice there is some, overlap between these labels and the component. But I think it matters less in our context, but because you already know the process, right? So essentially, the message I want to convey to you through these steps is with the help of AI agent, not only you can use your previously defined requirements to come up with a functional architecture, right? Remember those three functional architecture regarding the perception architecture: front camera, rotating camera, a mirror for two sides view, right? But also it can also help you to pick the most appropriate and cost-effective components. I think that's really the based on real-time price and based on real-time availability information, and that's very powerful. So with these, so the last thing, so let's get back to our the beginning. So let's get back to the beginning. I want you to keep this in mind. So to recap what we talked about this lecture. So we talk about how do we leverage the open source MCP server to have our AI agent do a lot of work for us, like creating common with functional design and pick components based on inventory price from the supplier. And we also walk you through, a real example using Claude Code, KiCad, and based on the parts information from GLC PCB. Again, don't feel like don't feel you need to stick with any of these tools or suppliers I talk about. I think what's more important is the concept, the process. Once you understand it, you can always use that to come up with your own Agentic AI architecture. So that's all for today. Thanks for watching.